Hello, geometry students. I hope you guys are ready to do some math together, because remember, this is not a vacation, it's just a corona-cation. So we're gonna jump into section 4 of chapter 9. We're gonna start with part 1, and we are discussing special right triangles. And the one that we're gonna discuss today is very special indeed. But first, let's talk about baseball, because I know some of y'all are sad because you can't play baseball right now. So we have your typical baseball field. You've got home plate, first base, second base, third base, and you notice that it takes 90 feet to get in between bases. And hopefully you're following along in your notes. All right, so it says, suppose we want to know how far the home plate is from second base. That's our goal. We want to know what it is. What can we do to find this out? Well, some of you guys might be thinking the Pythagorean theorem, and you would be right. When can we use the Pythagorean theorem? Anytime you have a right triangle. And clearly this right here would be our right angle, and there is our right triangle. So the 90 feet represents the legs. All right, so the 90 feet, those are the legs. The hypotenuse, that's what we're trying to figure out. That's the unknown. So I'm going to call that x. And I should be using a different color there that might show it better. Oh, that looks wonderful. Little pop of color. All right, so the 90 feet, the distance between the bases, those are our legs. The hypotenuse is what we're trying to figure out. So it says, what kind of triangle is this? Well, I did already give that away, didn't I? It is a right triangle, but there is a second answer. Can you guys think of it? It's right and it's isosceles, because these two sides are the same measurement. So we have two answers there. And it says, this means that the measures of the angles of this triangle are 45, 45, 90. And you might be wondering, well, how did she figure that out? And I will let you know. Remember, with an isosceles triangle, it means that not only do you have two sides that are the same, but it also means that our base angles are congruent. So going back to my picture, got the right angle. I know this is 90. I know this is 90. 90, sorry. And that means that this angle and this angle, those are my base angles. They're the same. Well, I've already used up 90 degrees right here. And if a triangle has a total of 180 degrees, that means there's 90 degrees left that has to be broken into two equal parts, thus making this 45 over here and 45 over here. So anytime we're dealing with a 45, 45, 90 triangle, two things that we know: we have a right triangle and we have an isosceles triangle. All right, so here this scenario says, let's suppose that we don't know how far the bases are from each other. So what if you were on a different baseball field and they weren't 90 feet apart? We don't know what that would be. Let me draw my triangle again real quick. So we've already labeled this side x. This side is also going to be x, because remember, this is an isosceles triangle. And it says that we are going to use the Pythagorean theorem because we still want to come up with that distance from home plate to second base. So again, go into our picture. Let's see how that would work. So we've set up the Pythagorean theorem. We have the legs, we're squaring them, we're setting it equal to the hypotenuse squared. These are like terms. Remember, in order to be like terms, the base has to be the same and the exponent has to be the same. So x squared plus x squared turns into 2x squareds. Now remember, our goal here is we're trying to solve for d. So how do I get rid of that squared? Do you remember? Hopefully you remember that that means that we're going to square root both sides, because whatever you do to one side of the equation, you have to do to the other side as well. So I'm square rooting both sides. Now remember, x squared simply means x times x. So what that tells me is that I have a pair. And remember, we've been dealing with these radicals all year. If you have a pair, guess what you get to do? You get to take it out. So we get to take the x out. The 2 has to stay underneath the radical because it didn't have a pair. And so our distance would be whatever the leg is times the square root of 2. And that's going to occur every single time you have a 45, 45, 90 triangle. If you know the leg, then all you have to do to get to the hypotenuse is multiply by the square root of 2, which is what this theorem is telling us. So it says that the hypotenuse is the square root of 2 times as long as the leg. So going back to the example where we had 90 feet in between our bases, it says let's use this theorem to find the distance between the home plate and second base. So in other words, instead of using the Pythagorean theorem, because we know that this is a 45, 45, 90 triangle, and I already know that my leg is 90, all I have to do is take my leg measurement, multiply it by the square root of 2, and that's going to be the measurement of my hypotenuse, which is what we were looking for in that picture, and our units are feet. So as long as it's a 45, 45, 90, you're just going to take your leg and multiply it by the square root of 2. All right, so example 2 says find the value of x and y and leave your answer in radical form. Just means we don't want decimals, we're not going to use a calculator, we're just going to leave it as a radical. So let's take a look at what we've got. We have a 45, 45, 90 triangle, which means that it's a right triangle and it's isosceles. And if it's isosceles, what does x have to be? You may have guessed it, x has to be 10 because our legs are going to be congruent. Now to get to the hypotenuse, which is labeled y, we're going to take our leg and we're going to multiply it times the square root of 2, and that's it. We are done with that problem. All right, example 3. Same idea, we're going to find the value of x and y. So again, we have this 45, 45, 90 triangle. We know that these two sides are the legs, so they're going to be equal. But there is something different about this problem. Can you identify what it is? You might have noticed that they didn't give us a leg this time. They gave us the hypotenuse, which changes what we do a little bit. So previously, to get from the leg to the hypotenuse, we were multiplying by the square root of 2. So we were going from a short side to a long side. But in this particular problem, we're no longer going from a short side to a long side. We're going to go from the hypotenuse, which is the long side, and we're going to get to the leg, which is the short side. And so what are we going to do? We're going to do the opposite of multiplying by the square root of 2. We're going to divide by the square root of 2. So if you have the long side, the hypotenuse of a 45, 45, 90 triangle, instead of multiplying by the square root of 2, we're going to do the opposite, and we're going to divide by the square root of 2. Now this brings you back into some algebra that you may have forgotten because you probably haven't used it that much since you learned it in Algebra 1. So let's go over it together. It says final answers in math are generally not allowed to have a radical in the denominator. Now if you get as far as taking calculus, you'll have them. But for right now, for an algebra, geometry, algebra 2, pre-calculus, we don't like to have those pesky radicals in the bottom. So we have to do what's called rationalizing the denominator. So let's get back to this problem that we were just working on and see if we can figure out how to do it. So we're going to take that 13 that was our hypotenuse and we're going to divide by the square root of 2. Remember, we're not allowed to have a radical in the bottom. The only way that I can get rid of the radical is I need a pair. Well, if I have a 2, I'm going to need another 2 to go underneath that radical. But whatever I do to the denominator of my fraction, I also have to do to the top. So right now, I'm basically multiplying both the numerator and the denominator by the square root of 2. Because here's what's going to happen. I now have, in the denominator, a pair of 2's. That means 2 gets to come out. And in my numerator, 13 times the square root of 2 is just 13 on the square root of 2. Sometimes this is where students get a little confused, so I want to break this down real quick for you. See how the 13 is not under a radical, but the 2 is under a radical? You can't multiply those numbers together and make it a 26. So your numbers, if they're both on the outside of a radical, you can multiply or divide them. If they're both underneath the radical, you can multiply or divide them. If they are not in the same location, one's on the outside of a radical, one's on the inside of a radical, then you can't multiply them together and get a new number. You just get 13 on the square root of 2. What I can do, though, is I can look at that number and that number because they're both not underneath a radical, and I can ask myself, can I reduce 13 over 2? The answer is no, and so this is my answer, and it's going to be for both the x and the y because this is an isosceles triangle, and so those legs are going to be the same size. And so that's my answer for example number 3. All right, so example number 4 says find the value of x and y. We see a similar problem like the last one. What were we given? We're given the hypotenuse. So remember to go from the long side to the short side, we're going to take that hypotenuse and we're going to divide by the square root of 2. But remember, we're not allowed to have a radical in the denominator. So we're going to multiply both the denominator and the numerator by the square root of 2 because our goal is now that we have a pair of 2's, we get to take a 2 out in the denominator. In the numerator, again, this is outside of the radical, this is under the radical, so I'm not going to get to change that to a 48. I'm just going to write 24 on the square root of 2. But what I can look at is this number and this number because they're both not under a radical sign. Can I reduce 24 over 2? Absolutely. That's going to equal 12, and then I still have my square root of 2. Again, for this problem, that's going to answer both the x and the y because our legs are always congruent in a 45, 45, 90 triangle because it's isosceles. All right, so let's take a look at these problems, but what I would encourage you to do is maybe pause this for just a moment, try these 3 problems on your own, and then restart it. So pause, and now I'm going to keep going with these problems. So number 1 says the perimeter of a square is 20 centimeters. Let's review. Remember, perimeter means the distance around a figure. So I have a square. What do I know about squares? I know that all of those sides are going to be the same amount. And I know for this particular square that the distance around it is 20. If that means that all 4 sides are equal, if I take that 20 and divide it by 4, that means each side is 5. Does that make sense? I hope so. Then it says, let's find the length of the diagonal. So this is what we want. Well, let's take a look at what we've just done. And this is a great review of Chapter 6 where we discuss quadrilaterals. We know that a square has all right angles. We know that in a square, the diagonals bisect the angles. That means that this 90-degree angle has just been bisected into 45 and 45. Same thing has happened right here. That 90-degree angle has been bisected into 45, 45. So we have the new shape we've been discussing today. We have our 45, 45, 90 triangle. We're trying to find out the hypotenuse. Remember, that is the long side. So how do I get from short to long? All I have to do is take the short side, multiply it by the square root of 2, and so our answer should be the letter B. All right, let's take a look at number 2. It says find the value of x. Again, we have a 45, 45, 90 triangle, but this time they haven't given us the short side. What we have been given is the long side, the hypotenuse. So we're going to take our 50 and we're going to divide it by the square root of 2. But we are not allowed to have a radical in the bottom. We're going to rationalize the denominator by multiplying both the numerator and the denominator by the square root of 2. So in the denominator, we have a pair. That means we get to take out a 2. In the numerator, we're going to have 50 on the square root of 2. But we get to take a look at the 50 and the 2. They're both outside of a radical. And ask ourselves, can we reduce that? Absolutely, because 50 divided by 2 is 25. And so we're going to end up with letter D, 25 times the square root of 2. All right, last one. It says the area of a square is 64 centimeters squared. So again, we're dealing with the shape that's a square. We've talked a lot about that this year. We know that all of these angles are right angles. We know that all of these sides are equal. How do we find an area of a square? You have 2 options because a square is a rectangle. So you could use base times height. You could use length times width. We actually have 3 options because remember, we also learned that the side squared is equal to the area. Well, we know that the area is 64. So how do I find out the side? Easy. I'm going to square root both sides, and we find out that each side is 8. But we're not quite finished with the question yet because the question is, what's the length of the diagonal? we just talked about the fact that this diagonal makes this a 45, 45, 90 triangle. So we get to take our short side, the leg, and multiply it by the square root of 2 to get the hypotenuse, and that's going to give us letter C. All right, so if there's anything that you didn't understand from this lesson, please go to my website, type in your questions into the blog. That'll give me some insight as to how you're doing. You have a worksheet that's in your packet that goes with this lesson. Remember, when you're done with that, take a picture of both sides, send it to me, and then I'll get started making the next video, which also talks about a special right triangle. See you guys in the next video.